So let's begin with the next topic, that is the position versus time graph. Okay, so again let's come to the same example. Suppose this is me and I am walking along this straight road and there is this tea shop. Okay, so suppose and then here, okay, there is some newspaper, okay, newspaper shop. So I go like this, I walk along this straight road, then I take tea over here, or I keep on walking and I go to that newspaper shop, then I come back and I stop here at the tea shop. I read the newspaper with a cup of tea. Okay, so this is my motion. Now suppose I want to plot it. Okay, so I will plot my position on this vertical axis and the time on the horizontal axis. So this graph may look like this, something like this. Okay, so initially my speed would be very zero. If I am starting the jogging in the morning, my speed would be very zero initially. Then I will increase my speed. Then once I see that newspaper shop, I will stop over there. Okay, so here my speed will become 0, and again now this is happening in very, I mean very fast, right? But in reality it won't happen that fast. But suppose the time I take the newspaper, okay, just like the players in the marathon, they pass on the baton. Okay, just like I take the newspaper, I come back over here and I stop over here. So the graph looks something like this, right? So this is position versus time graph. Now what kind of information do we get from this graph? So first of all, we can find out the average velocity between the start point and end point. What would be the average velocity? So at the start point, my position was 0, time was 0, and this is the end point, which is point C. Then my position is suppose something, okay, suppose that is x2 and time is t2. Okay, at the start point you can say position is x1, time is t1, and at the end point position is x2, time is t2. Then we can find out velocity. Velocity would be just equal to x2 minus x1 divided by t2 minus t1. That is my velocity. The change in position divided by change in time, that is the velocity, right? And what would be the speed? How will you find out the speed? So to find out velocity, what will you do? It is the difference between the positions of these 2 points. This is final position minus the initial position, okay, divided by the time. But if you want to find out the speed, that is total length of the path covered, yeah, that is distance divided by time. So total length of the path covered, so you will go from A to B, okay, you will calculate that distance, and then you go from B to C, you calculate that distance, right? So the average speed would be equal to just this total distance divided by the time. Okay, right? And which one would be greater? Velocity would be greater or speed would be greater? What do you think? Speed would be greater, right? Because distance covered is more than the displacement. Speed would be greater. Okay, now suppose this is any x versus t graph. So this is for the uniform motion. Okay, this is for the uniform motion. So slope of this graph will give us the velocity. Okay, so how do we find out the slope of a line? We learned it in basic mathematics, but anyways we'll just recall it. So suppose this is a straight line and I want to find out its slope. Okay, so this line is what? This is position versus time graph of any motion. Okay, so I want to find out the velocity. So what I will do is I will just take any 2 points on the graph, right? I can take this point which is x1 t1, okay, or this point which is x2 at t2, right? We write actually the horizontal coordinate first, so it is t1 x1, right? This one is t2 x2, and this point is t3 x3. So the slope is given by x2 minus x1 divided by t2 minus t1, or you can say it is given by x3 minus x2 divided by t3 minus t2, right? So you can choose these 2 points or you can choose these 2 points, or you can choose this point and this point, and you can find out the change on the vertical axis, which is called as rise, divided by change on the horizontal axis, which is called as run. Okay, so velocity is just slope of the position versus time graph, that is the average velocity, and we know that the slope is equal to, suppose this line makes some angle with the vertical axis, sorry, horizontal axis, that angle is theta. Okay, this line makes an angle theta with the horizontal axis. Then what is the slope? Slope, if you see, it is the tan of this angle theta, right? It is just tan of this angle theta, right? So see here, x2 minus x1 is this much difference. So if you consider this triangle, then it is this opposite side divided by adjacent side, right? So x2 minus x1 divided by t2 minus t1 is just tan of theta. Okay, so these are two different ways of finding out the slope, right? Now let's come to this point. So suppose this is x versus t graph of two students, or you can say two cars, anything, any two. So this is A. Okay, this is position versus time graph of A. This is position versus time graph of B. Which one is faster out of these two? B is faster or A is faster? Who is faster? B is faster, right? Because slope of B would be greater than slope of A. Yeah, angle is more. So slope of B is greater than slope of A. Right? This is very, very simple. B is faster compared to that of A. Okay. So then now okay, so this is simple. After that, now we are studying graphs for motion. So first type is x versus t graphs. Okay, that we started with. So now let's consider various cases for this x versus t graphs. Okay, so suppose object is at rest. How will its position versus time graph look like? It looks like this. It's a straight line. Okay, it's a horizontal line, right? It's parallel to time axis. Why? Because suppose the object starts from this position. So at t equal to 0, it's here. At t equal to, let's say, 1 second or something, it's here at the same position. At t equal to 2 seconds, it's here at the same position. If you join all these points, what will you get? You get a straight line, okay, parallel to horizontal axis, right? Then if object moving with uniform velocity, if object is moving with uniform velocity, then what happens? The graph will look like this. Okay, we can plot it. The graph will look something like this. And then next is uniformly accelerated motion. So for uniformly accelerated motion, the graph will look like this. And if the motion is retarded means decelerating motion. Okay, if velocity decreases, then graph will look like this. Okay, for uniformly accelerated motion, the graph will look like this. For uniformly retarded motion, the graph will look like this, right? So now you can think of it from here actually. So see, now suppose velocity of B is greater than A, that's clear, right? And suppose A wants to increase its velocity. Okay, A wants to increase its velocity. So its position versus time graph, it will change like this, right? Suppose A wants to increase its velocity. So what will happen? Its position versus time graph, it will start like this, but it wants to increase the velocity. So it's increasing, so it will go towards B, because here the velocity is increasing, you can say. Okay, because velocity of B is greater than A. So if position of A changes like this, that means A is running faster. So this would be the graph of accelerated motion. Okay, on the contrary, suppose you can think of B wants to decrease its velocity. Okay, so how will its position versus time graph look like? So B decreases its velocity, and its velocity at some time becomes equal to that of A. So position versus time graph of B will look like this. Okay, it will start along this line of B and then it will tilt towards what? A. So this is the graph of retarded motion, okay, decelerating motion. This thing is clear? Yes, no? Everyone? Okay, good. So this is the position versus time graph. So this is object at rest, uniform motion, uniformly accelerated or uniformly retarded motion, right? Then if nothing is uniform, then it will look something like this. So this is not at all uniform motion, right? Okay. All right. Then next, let us see velocity versus time graph. So in case of velocity versus time graph, if your object is at rest, how will its velocity versus time graph look like? So it will look like this. Why? Because at t equal to 0, your object is at rest. That means velocity is 0. At t equal to 1 second, the velocity is 0. At t equal to 2 seconds, the velocity is 0. So if you join all those points, then you will get what? You will just get this horizontal line, and it is just time axis. It's not parallel to time axis. It is time axis. Right? This is clear? Okay, good. Then for uniform motion, if velocity is constant, velocity is not changing. So velocity versus time graph will look like this, right? Velocity versus time graph will look like this, right? Because at t equal to 0, the velocity is suppose v naught, 2 meters per second or something like that. At t equal to 1 second, still the velocity is v naught. Okay, so same velocity. T equal to 2 seconds, same velocity. So therefore the graph will look like this. Then comes the point, if it is uniformly accelerated motion, if it is uniformly accelerated motion, that means the velocity is increasing uniformly. So it will look like this. It will look like this, right? The graph will be a straight line. Okay, it will look like this, and slope of that line will give you what? Acceleration. Okay, but now suppose acceleration is increasing, then how will the graph look like? Then the velocity versus time graph will look like this. Okay, increasing acceleration. If acceleration is constant, velocity versus time graph will be a straight line. If acceleration is increasing, the graph will look like this. If acceleration is decreasing, then the graph will look like this. Okay, this is clear, everyone? Good. So this is uniformly accelerated. This is for the acceleration is increasing. This one is for the acceleration is decreasing, and this one is for the acceleration. It's with negative acceleration. So here the velocity is increasing uniformly. Here the velocity is decreasing uniformly. Right? Velocity is decreasing uniformly. Okay. So this one is for uniformly retarded motion. Okay. All right. So now we have seen that if you find the slope of position versus time graph, it gives you velocity. Okay. So now from velocity versus time graph, we get two pieces of information. One is you get displacement, and one is you get the acceleration. Okay. So see how. So just for an example, let's consider simple graph that velocity is constant. Okay, velocity is what? Constant, right? So here, see, we know that velocity is what? Change in position divided by change in time. This is displacement upon time. So x2 minus x1 is displacement, t2 minus t1 is time. Take t2 minus t1 on this side. So what do you get? You get x2 minus x1 is equal to v into t2 minus t1. Right? x2 minus x1 is equal to v into t2 minus t1. And if you see that on this graph, what is v? V is the velocity. What is t2 minus t1? T2 minus t1 is this side. So if you just see it over here, v is this side, okay, of this rectangle. Yeah, it's the area. And t2 minus t1 is this side. So v multiplied by t2 minus t1 will give you area under this curve, and from where to where, that is important, it will give the area from t1 to t2. Okay, so this area is what? It's equal to x2 minus x1. That means it is equal to the displacement of object from time t1 to time t2. Okay, so area under the vt curve from t1 to t2 is equal to the displacement of the object from time t1 to time t2, right? Okay, this thing is clear. All right, good. Then next thing, so suppose this is the velocity versus time graph. We can take any velocity versus time graph. Okay, we can take this one as well, but now I wanted to find out the slope, and slope of this one is 0, velocity is constant, right? So we know acceleration. What is acceleration? Acceleration is change in velocity divided by time. So it's final velocity at some time t2, you can say, okay, or velocity at time t2 minus velocity at time t1 divided by t2 minus t1. Okay, it is the acceleration, right? Change in velocity upon time. So here if you see that on the graph, acceleration will be the slope of velocity versus time graph, because if this is time t1, this is time t2, this one is velocity at time t1, this one is velocity at time t2, right? This is the velocity at time t2, v2. V2 is the velocity at time t2. Then v2 minus v1 is this much length, okay, or this much length, that is change on the vertical axis, divided by t2 minus t1 is change on horizontal axis, and change on vertical axis divided by change on horizontal axis gives us what? Slope. Okay, so the acceleration is given by the slope of velocity versus time graph, right? This thing is clear, everyone? Okay, good. And then next one is AT graph. AT means acceleration versus time graph. So if for uniform motion it will look like this, because acceleration is 0. For uniformly accelerated motion, so now here sometimes students get confused that this graph is acceleration versus time and you want it for uniformly accelerated motion. Okay, so for uniform motion, velocity versus time graph is flat. For uniformly accelerated motion, the acceleration versus time graph would be flat, like this. Okay, so we need to remember which motion we are talking about, right, in order to draw the graphs or understand the graphs or identify the graphs, right? Okay, so this one is for uniformly accelerated motion, this is for increasing acceleration. Now this one can be like this also, it can be like this also, because if I draw like this, still the acceleration is increasing. Okay, so this is also for increasing acceleration, but this is uniformly increasing acceleration, right? And this is decreasing acceleration, so this is uniformly decreasing acceleration. These graphs are clear? Yes, no? Okay, good. And then what do we get from the acceleration versus time graph? So if we find out the area under acceleration versus time graph, we get the change in velocity. Which graphs? These graphs?
Yes, sir.
Increasing acceleration.
Uniform motion and uniformly accelerated motion.
Uniform motion and uniformly accelerated motion. Okay, so uniform motion is like, see, example can be anything. Suppose you take your bike, okay, you're riding on your bike and you constantly see 40 kilometers per hour. That is uniform motion.
Yes, sir.
And if you just uh, if you just accelerate the bike, what will happen? It will go from 40 to 50, something like that. Okay, it happens in no time for the bike, but suppose it takes some 10 seconds. So that is the uniformly accelerated motion,
Okay, sir.
right? If you want to see natural example, the natural example is motion upon motion of an object under the gravity. Okay, if you release something, if you drop some object from some height, it falls down under the gravitational acceleration. So that motion is uniformly accelerated motion,
Okay, sir.
right?
Okay, sir.
Okay, but that acceleration is negative. So if you want to plot the graph of gravitational acceleration versus time, it will not look like this because the acceleration is negative. It will be below the time axis. Okay, for gravity, the graph will look like this.
Okay, sir.
Why? Because the acceleration is negative.
Negative.
Okay, so a is equal to minus g. Minus g means minus 9.8 meters per second squared, right? Acceleration is negative, meaning it's in negative direction. Okay, right? It's along negative y-axis. That's why the graph will look like this. Sorry. So this is simple, right? Okay, so now we need to remember these things. The slope of position versus time graph gives velocity. Okay, slope of position versus time graph gives velocity. Then from velocity versus time graph, you get two things. One thing is if you find the slope, you get acceleration. Second thing is if you find the area under the curve, you get displacement, right? And from acceleration versus time graph, if you find area under the curve, you get change in velocity. Okay, from acceleration versus time graph, if we find the area under the curve, we get change in velocity. So this is clear, right? Then now let's see simple problems. The acceleration of a moving body is found from the, tell me, area under the vt graph, velocity versus time graph, area under displacement versus time graph, or slope of distance versus time graph, or the slope of velocity versus time graph, area under the acceleration versus time graph. Which one is correct? Yeah, very good. It's option D. Okay, let's see next one. In the figure below represents a parabola. Identify the physical quantities representing y and x for a constant acceleration. If acceleration is constant, then what will be y and which thing will be x? Tell me. X is time, y is velocity, or x is velocity, y is time. X is time, y is, okay, Yamini is saying it's option C. X is time and y is displacement. Yeah, very good. It's option C. Okay, so we just saw the position versus time graph, or you can say displacement versus time graph of uniformly accelerated motion will look like this. So this is also very simple, right? It's from KCET, Karnataka CET. All right, let's see next one. The speed time graph of a particle moving along a solid curve is shown below. Okay, speed time graph is shown below. The distance traveled by the particle from t equal to 0 to t equal to 3 seconds is, tell me, distance traveled from t equal to 0 from here to t equal to 3 seconds is. So this is speed versus time graph. What will we do? So distance is equal to just area under the speed time curve, right? It's just area under the speed time curve. Okay, so that is equal to, what is the area under this curve? So it is half of base into height. This is just a triangle, right? This is just a triangle, so it's half of base into height. So what is base? Base is 3. What is height? It's 1.5. So it's half of 3 times h is 1.5. Okay, so that is 4.5 divided by 2 means, that is correct, no? 4.5 divided by 2, that should be the answer. You want t equal to 0 to t equal to 3 seconds, right? 2.25 should be the answer. Okay, so out of these, none of the options is correct, right? So let's say it is E is equal to 2.25. Okay, correct, no? I don't think I can make mistake in this one. Yeah. Okay, so let's see next one. The displacement time graph of two moving particles make angles 30 degree and 45 degree with the x-axis. The ratio of their velocities is. So we know what is the velocity. Velocity is given by, if you have angle made with the x-axis, if you have position versus time graph and the graph makes some angle with the time axis. Okay, x-axis means time axis here. Then what is velocity? It is tan of theta, right? So what is, you want ratio of their velocities, tan 30 to tan of 45, right? Tan 30 to tan 45. Is it option D? Okay, so tan 30 to tan of 45. So that's equal to, what's tan 30? Tell me.
1 by root 3.
1 by root 3, right? 1 by root 3. And what is tan of 45? Tan 45 is 1. Okay, so that is just equal to 1 by root 3. It's very, very simple. Okay, so it's option D. All right, so if we remember this, then it's very simple. All right, let's see next one. These are very, very simple questions. Okay, we are starting with simple questions. All right, which of the following graphs cannot possibly represent one-dimensional motion of a particle? Which of the following graphs cannot possibly represent one-dimensional motion of a particle? Anyone? Is it option B? B says 2 and 3. 2 and 3 don't represent the one-dimensional motion. Why is it so? Yes, Yamini? Yeah, because at one time they should have only one velocity and only one position, right? So for an example, if we think of this graph, okay, this is position versus time graph, and then if you just take some time, time is this one, suppose, okay, and you draw a straight line on the graph, then what will happen? You get these two positions, okay, this position as well as this position, right? So at this time the graph is saying that object was here also and object was here also. So it is not possible, right? For real objects it's not possible, it's not the God. Okay, I don't know God is, okay, whether God is there, if he or she, if it is present everywhere, right? We say that, no? So but objects in the real life, they can't be present at two different positions at the same time. Okay, yes, no? So this graph cannot represent the motion, okay, motion along a straight line. Anyways, let's come over here. So this is velocity versus time graph, and same goes with this one also. If we take some time, for an example, let's say this time, okay, so at this time the velocity of object is this one as well as this one. So you can say object is moving towards right as well as towards left. So this is not possible, okay, for real objects. So this is also incorrect. So that's why 2 and 3 is incorrect, and that's why the answer is option B. Okay, good, very good. All right, let's see the next one. Figures 1 and 2 show the displacement time graphs of two particles moving along the x-axis. We can say that this is the first one, this is second one. Okay, tell me. We have discussed both cases. Both particles are having uniformly accelerated motion. Okay, very good. Everybody is saying it's option C. So particle 1 is having uniformly accelerated motion and particle 2 is having uniformly retarded motion. Very, very good. So it's option C, right? Let's see next one. Area under the velocity time curve over a given interval of time represents. Tell me. Area under VT curve. It's option A. Good. What? Area under the VT curve. Area under VT curve. Yeah, it's D. It's not A. Okay, I was also, clicking A and I saw acceleration there. All right. So it is option D, displacement. Good. So see, these questions, these are given for just for one sake of one thing, they can be asked. Okay, and one more thing, if you just revise the questions, if you just go through the questions, okay, then if you forget some concepts, okay, the concepts will become clear also, right, at the last moment also. Area under the VT curve, if you forget about it and if this thing is in front of you, okay, it gives displacement, right? All right, let's see next one. A body starts from rest and moves with uniform acceleration. Which of the following graphs represent its motion? Starts from rest and moves with uniform acceleration. So starts from rest means initial velocity must be 0. So it's 0 here, it's 0 here. Okay, but then this graph goes like this. So this is retarded motion. Actually, no, initially velocity is increasing, no, yeah, initially velocity is increasing, then it becomes constant. It's that kind of motion. Okay, but here velocity is uniformly increasing. So this one is the answer. This is for the uniformly accelerated motion. Okay, very simple. All right, a body moves with uniform acceleration, then which one of the following graph is correct? Same question. So it is again this thing, uniform acceleration, right? Okay, let's see next one. The area of acceleration displacement curve of a body gives. So now can you think about this one? Area of acceleration displacement curve. On one axis, what is plotted? Acceleration is plotted, and on another axis, displacement is plotted. Okay, and let's say for simplicity, acceleration is constant. Okay, So then this is some x1, this is x2, and this is acceleration. If you take area under that, this curve, so area will be equal to what? It is acceleration. Okay, this is acceleration multiplied by x2 minus x1. Okay, acceleration multiplied by x2 minus x1. So tell me, or you can say this is the displacement. This is a times s. It is option C, change in kinetic energy per unit mass. Very good. Okay, you have this thing a times s, then you remember v square minus u square is equal to what? 2 times a into s. Okay, but then if you take that 2 on this side, it becomes half v square minus half u square is equal to a into s. And if you remember the formula for kinetic energy is given by what? Half of mv square. Okay, so if you take kinetic energy per unit mass, what do you get? You get half v square. So this is final kinetic energy per unit mass. Okay, kinetic energy divided by mass per unit mass, and this is initial kinetic energy per unit mass. So this thing is change in kinetic energy per unit mass, right? This is change in kinetic energy per unit mass, and it's equal to a times s, means it is area under this curve. Okay, so it is option C. This one is clear, everyone? All right, good. Okay, then let's see this one. Consider the given velocity time graph. It represents the motion of a projectile projected vertically upward from a point, an electron in hydrogen atom which revolves like this, okay, in circular motion, a car with constant acceleration along a straight road, a bullet fired horizontally from the top of a tower, and an object in positive direction with decreasing speed. Which one? What's happening to the velocity? This is velocity time graph. So the velocity is decreasing. Here at this time it becomes 0. Then it's increasing in negative values. It is option D. So D is a bullet fired horizontally from top of a tower. No. Somebody else said something else. Option A, a projectile projected vertically upward from a point. Is it correct? When you throw a projectile upwards, okay, initially the velocity is maximum, then velocity goes on decreasing, and direction is upwards, so you can take it as positive. So if we take this direction as positive, then velocity, what happens to the velocity? Initially it is maximum, then it goes on decreasing, and it stops at some point. So velocity at that point becomes 0, right? Velocity there becomes 0, and again it comes back. So again the velocity increases, but it increases in negative values. Okay, the velocity increases in negative values. So this is correct, right? This one is correct. So it's a projectile projected vertically upward from a point. Okay, so its velocity versus time graph will look like this. Good. Let's see next one. A boy begins to walk eastward along a street in front of his house, and the graph of his displacement from the home is shown in the following figure. His average speed for the whole time interval is equal to, tell me. You want to find out average speed. What will you do? This is displacement versus time graph. Tell me what will be the average speed? Okay, what will be the average velocity from here to here? Average speed is, you are saying average speed 8 by 3 meter per minute. So what did you do? Tell me, Vishalini. Distance into time. But distance into time, will it give you speed? Distance divided by time. Okay. Yeah. So what is the total distance? It's 40. Okay, 40, and then it comes back here. So 40 plus 40 is 80. 80 plus, how much is this? Is it 10? Oh, the graph is not good. The graph is starting from here. Okay. I guess it should start from 0. But this is 0, this is the 20. What would be this thing? 5 or something? I think this is a misprint. Okay, for the sake of understanding it, I will just shift the 0. Okay, the final answer may not match with what's the answer over there, because I don't know. Okay, so I will just mark 0 over here. Okay, so this is a new problem, you can say, because marking there is, it's not clear. So if this is 0 and that's 40, then it will be 40. Okay, distance covered is 40. When it comes back again, the distance covered is 40, and then I guess this should be 10. So, or yeah, this should be 10. So 10 and 10, so it's 40 plus 40 plus 10 plus 10. How much is that? It's 100, right? 100 divided by time taken is what? 20. So that is equal to 5. Okay, but 5 is not there, so I guess this should be then 20 only. Okay, so I'm just trying to guess. So let's say that this is 20. All right, so if this is 20, then it will be 6. This thing is clear? Yes, no? I have just changed the question, nothing else. Okay, because the marking was not clear, I have changed the question in such a way that answer will match with one of these answers. Anyways, let's see. So we want to find out average speed. So object goes from here to here, right? This is displacement. So average object displaces from 0 to 40, then from 40 to 0. Okay, he goes over there, stops there, comes back. Okay, so this is 40. Again he comes back. So this is 40. 40 plus 40 is 80. Right, then he goes in negative direction. Okay, if you think about right and left, object goes in this direction, then comes back, then goes towards left. Okay, and comes back. Right, so this is 40 plus 40, 80. 80 plus this is 20 plus 20, so that means 40. Okay, so 80 plus 40, total distance covered is equal to what? Total distance covered is 120, and total time taken is what? From 0 to 20 minutes. Okay, so 120 divided by 20, it will be 6 meters per minute. Okay, so that's the answer. This is clear, everyone? Yes, no? Okay, Diveshwani, is it clear? All right, good. So this is question is very simple, but the diagram was not clear. Anyways, all right. So let's move on to the next thing, that is instantaneous velocity. So now we know how to find out the average velocity, right? What is the instantaneous velocity? So once again, we had discussed this thing when we discussed mathematical methods, right? So suppose this is the position versus time graph, and it looks like this one. Okay, so this is the position versus time graph, and I want to find out the velocity of this object from time t1 to time t2. What will I do? So what I will do is I will just take the change in position, okay, which is this one. Okay, this much is the change in position divided by change in time, so that's t2 minus t1, which is this much. So average velocity is x2 minus x1 divided by t2 minus t1, right? And then that average velocity is given by slope of this line. Okay, it is given by slope of this line, and this line is known as what? Secant line. Okay, this line is known as secant line. So if you take first point on the graph, if you take another point on the graph, draw a straight line passing through those 2 points, slope of that line will be equal to what? X2 minus x1 divided by t2 minus t1, and that slope will give you the average velocity from t1 to t2 in that time interval. Okay, then now if you decrease the time interval, so instead of this t2, suppose I take this t2 dash, and I want to find out the velocity from t1 to t2 dash, then what happens? So then what happens is you get the velocity which will be slope of this line, which will be given by slope of this line. So this line is again a secant line. Okay, it intersects the graph at 2 points, but you can notice that this line is approaching closer to the graph. It's coming closer to the graph. Okay, so then if you decrease the time interval even more, if you take this time interval, let's say from t1 to t2 double dash, then what happens? The secant line again approaches closer and closer to the curve. So if you keep on doing this, what will happen? At a very small time interval, when time interval becomes very small, this line becomes tangential to the curve. It will approach very close to curve, and it will not intersect, because see, distance between these 2 points is also decreasing. Okay, so it will intersect the curve at one and only one point, and that line is known as what? Tangent. Okay, so that's what it is shown here. So if you decrease the time interval, so see, this time interval is very small compared to that one. So then what happens? The line passes, still this is appreciable time interval, right? So again the line will pass through 2 different points, right? So this will be still a secant line, but if you decrease the time interval even more, what will happen? So this line also, it's almost tangential to this curve. Okay, so if you make the time interval equal to 0, then what happens? The slope of a line which gives what? A line whose slope gives you the velocity, it becomes tangential to the curve, and that velocity is known as instantaneous velocity. So what is instantaneous velocity? It is velocity of an object in very small time interval. Okay, what instantaneous means? Right now. Okay, if you want velocity, right, you say I want the velocity, you get the velocity. Okay, that is instantaneous velocity. And how do you get that? From the xt curve. From xt curve, it is the slope of a tangent line, right? If you want velocity at time t1, you just draw a straight line like this. Okay, it will meet the graph over here. So this is point corresponding to what? Time t1. Just draw a tangent there. Then slope of the graph and slope of the tangent at that point will be equal. That means the velocity will be slope of the tangent to the graph. This thing is clear? Yes, no? Everyone? Okay, good, very good. So this slope gives us instantaneous velocity, and then now if time interval is very small, we know that we write it like this: limit delta t tends to 0, x2 minus x1 is written as delta x, t2 minus t1 is delta t, and this thing is called as what? Derivative of position with respect to time. So the instantaneous velocity is given by derivative of position with respect to time. Okay, instantaneous velocity is given by derivative of position with respect to time. All right, and what is the geometric meaning of derivative? It is slope of a tangent line. Geometric meaning is slope of a tangent line. Okay, so this is the formula. Instantaneous velocity is given by derivative of position with respect to time. All right, then if we come to the VT graph, velocity versus time graph, and similarly we know that just like velocity is change in position upon time, acceleration is change in velocity divided by time. And if you want instantaneous acceleration, always remember this: when you have separate times, okay, then the quantity that you are finding out, any quantity, maybe it's velocity, maybe it's acceleration, whatever it is the average value of that quantity, right? And if you want instantaneous value of quantity, what do? You just take derivative. Okay, so acceleration is change in velocity, v2 minus v1 divided by t2 minus t1. Okay, v2 minus v1 is written as delta v, t2 minus t1 is written as delta t. Instantaneous acceleration, the instantaneous acceleration is what? This delta t becomes very small, limit delta t tends to 0, delta v by delta t, and it is dv by dt, derivative of velocity with respect to time. Okay, this is clear, everyone? All right, good. So this is when you find out derivative, you get this thing. Okay, and then the next is area under the VT graph. Okay, we know that area under the velocity versus time graph gives us what? Displacement. Okay, area under the velocity versus time graph gives us displacement. So what is displacement? It is just area under the velocity versus time graph, and the graph is simple one like this. Then finding out area is very simple. It's just this side multiplied by this side, right? But if you have a complicated graph like this one, then what you do is you break down this one, okay, this total interval into n number of small segments. Then you find out area of one such segment. So this is t1 to t2 is the interval. You break it into small segments and you find area of one segment. So what will be area of one segment? So you can say it is just v multiplied by the width of the segment, it's delta t, let's say. So v times delta t. Okay, or velocity at this point is suppose v1, velocity at this point it's v2. So you keep on doing this, v1 times delta t plus v2 times delta t, you will get this segment, area of this segment plus area of this segment plus area of this segment, so on and so forth. And you say that approximately that is equal to area under this curve. Okay, so approximately we say that it is equal to area under the curve, and this approximation will increase if we take, see here itself you can see here the width of segment is this much, so you have this much of error. Okay, so the area that you are calculating is v1 times delta t, so it is this area, right? It is this area. So this blue shaded region is the error. Okay, you're counting that much less. This one, in this one, this is the error. Okay, so you are counting that much less, right? So this is the error, this is the error. So if you divide into n number of segments having width equal to this much, okay, and you are saying that area under the curve is area of all those segments, then you are committing some error, right? So it will be area of these small triangles. If you add up the area of all those small triangles, you will get the error. But then instead of taking this much width, if you take this much width, okay, smaller width, half of the width, then what will happen? So see, then area under the curve, you will approximate it to area of this segment plus area of this segment, and here you can see the error is reduced. Okay, this is the error now. So compared to this one, compared to this case, the error here is reduced, right? So if you divide the time interval into more number of segments, if you chop the time interval into larger number of segments, then what will happen? Error will be reduced. Then area under the curve will be approximately equal to sum of areas of all those segments. And how to do that? If you divide the time interval into small segment, means you will need to divide it into more number of segments. So number of segments will approach to infinity. Okay, so what is the displacement? It is sum of all these small areas, you can say. Okay, so that is v times delta t. Okay, v1 delta t plus v2 delta t. So sum of all those is written like this: summation I goes from 1 to n, vi times delta t, right? And then now if we take n very large, and we take very large, that means n tends to infinity, then we replace this summation symbol by the integration symbol. So what is integration? Integration is also sum only, right? It's a continuous sum. So where you have this segment divided into infinite number of, interval divided into infinite number of segments. Okay, so when number of segments becomes what? Infinity, then summation becomes an integration. Okay, and we had seen this in basic maths, that this is what, this thing is the fundamental theorem of calculus. So what does the fundamental theorem of calculus say? That suppose v is equal to dx by dt. Okay, if v is equal to derivative of x, then if you integrate v, you get x2 minus x1. Okay, if you integrate v from t1 to t2, you will get what? x2 minus x1. Okay, so you recall this, right? You remember this? Okay, good. All right. So then similarly, so x2 minus x1 is the displacement. It's given by area under the velocity versus time curve, and now we'll remember it like this. So if you have a curve something like this, that means v is some function of time. Then how will you find out the area under the curve? To find out area under the curve, what will you do is you will just integrate this v from t1 to t2. Okay, how will you find out the area under the curve? You will just integrate v from t1 to t2. That will give you area under the curve. So area under vt curve gives displacement. That means displacement, or x2 minus x1, is just equal to integration of v dt from t1 to t2. Displacement is area under vt curve, means it is integral of velocity, right, from t1 to t2. Similarly, change in velocity is area under the acceleration time curve. That means that what is change in velocity? So change in velocity is integral from t1 to t2 of a dt, acceleration. Okay, it is integral of acceleration from t1 to t2. and dt is there just to show that the time is variable. Okay, this thing is clear, everyone? Right? And this thing, actually we have seen all of this in basic maths, but just recalling this, if h is equal to dg by dx, if h is derivative of x, then if you integrate h, what do you get? If you integrate h from x1 to x2, you get the value of g at x2 minus value of g at x1, right? So it simply means if h is derivative of g, then integration of h is derivative of g, then integration of h will give you what? It will give you g back. Okay, if a is derivative of b, then b is integral of a. That's the meaning. A is derivative of b, b is integral of a, right? All right, so this thing actually I have explained it. So area under the acceleration versus time graph, how will you find it out? Area under any graph, how will you find out? So this quantity, okay, you are plotting along the vertical axis, you want to find out area of this quantity, right? Area under the graph means, so you will write it like this, it is area of acceleration versus time graph, it is a times dt. Take the quantity on the vertical axis, that is a, take differential means delta t you can say, but we write it as dt here while taking integral. Okay, so take quantity on vertical axis, that is a, then what is quantity on time axis? It's horizontal axis, it's time. So here you will take a dt. Okay, quantity on vertical axis, quantity on horizontal axis, you will write it as d times that quantity. Okay, if it is time, then it is dt, if it is distance or position, then it is dx, and then you integrate it from initial time or whatever that quantity is to final time, so t1 to t2. So this area under acceleration versus time graph, what does it give? It gives us velocity, change in velocity, right? Velocity at final time minus velocity at some initial time t1. Okay, so tell me if there is a question in this, anyone? Do you have any question in this? All right, good. So I went a little bit fast because we have seen these topics in basic maths. All right. Okay, so this is similar question. Actually, I should have taken it along with those questions. Anyways, which of the following curve does not represent motion in one dimension? It's option B, right? All right, let's come over here. The displacement time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at the point. Where is it negative? So option A is E, right? Good. Yeah, everyone is saying option A, right? Option A means point E. So what is the velocity? It's slope of the displacement time graph or position time graph, you can say. So this point at point C, if you draw tangent to the graph, it's like this. So its slope is positive. That means velocity is positive. Okay, at point D, it is flat line. So it's horizontal to time axis, means at this point the velocity is 0. At this point the slope would be like this. So the velocity is, at this point the tangent drawn goes like this. So velocity would be negative because slope is negative, right? So option A is correct. All right, let's see next one. A particle shows distance time curve as given in this figure. The maximum instantaneous velocity of particle is around the point. Tell me. A particle shows distance time curve as shown like this. The maximum instantaneous velocity is at a point. This is
C.
A. Is it at A? Point B? Yeah, I am also thinking
Point
it's.
C.
You think it's point C? Okay, let's draw a tangent. First of all, they have not marked the points. So let's mark points. Will it be B? So, okay. So again, we are just trying to understand this. So I am marking these points. Okay. So they have just written A, B, C, D. That doesn't mean anything. They should be points, right? Discrete points. So here you have point B. At A, it's not maximum. That is for sure. A is this point. Okay, at B, let's draw tangent at B. So this is tangent at B will look something like this. Tangent at C, yeah, tangent at point C will look like this, something like this. Okay, and tangent at point D will go something like this. So as I see, for me, it's the point C, right? Okay, yes, no, I think for point C it is more steep compared to point B also. Yeah, it's point C, right? Okay, convinced with me, everyone? Okay, good. So it is point C. Point C means option D. Okay. All right. That was very simple question. Let's see next one. If points are marked, that is very simple question, right? And in NEET, points will be marked. Let's see next one. Two cars P and Q start from a point at same time in straight line and their positions are represented by xp of t is something, at plus bt square, and xq of t is equal to ft minus t square. At what time do the cars have same velocity? At what time their velocity is equal? This is the question. So tell me. Velocity is equal, no? That is very simple. Just take velocity of first point Vp is equal to velocity of second point. And what does that mean? If velocity is equal means what is given? Their position is given in terms of time, right? So dx for p by dt is equal to dxq by dt. Okay, now put the values, put the equations. D by dt of at plus bt square is equal to d by dt of ft minus t square, and now take the derivative. So that is, what is derivative of first one? Derivative of first one, a, this is at, derivative of that is just a, right? This one bt square, so b you can take out, derivative of t square is just 2 times t, and therefore it is 2 times t into b. Okay, so 2 times t, sorry, it's a plus 2 times bt, and that's equal to, take derivative on right hand side, so it is f minus 2t. Okay, and just move this on this side, so this becomes 2bt plus 2t is equal to f minus a, right? And you can take t common, and then there is nothing in the question. It is f minus a divided by, if you take 2 common from sorry, t common from here, it's 2b plus 2, 2b plus 2, right? So that is the answer, or it is f minus a, that's there in only one option. It's option D, f minus a, right? And in denominator you have, you can take 2 also common, so it's b plus 1 or 1 plus b. Okay, so it is option D. This is very simple. Yes, everyone. Selva Kumar,
Yes, sir.
right? Indusha,
Yes, sir.
okay, good. Let's see next one. If the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 and 2 is, okay, tell me, what should I do? I want to find out distance traveled. Tell me. Velocity is given, distance traveled. Yeah, take integration. It's very, very simple, right? Distance traveled between 1 second and 2 second. So displacement is equal to, actually it would be displacement, not the distance. Okay, and it will be at plus bt square dt, so that is velocity. Or let me write this thing first. Displacement is what? Area under vt curve from some initial time to final time, t1 to t2. Okay, and what is v? V is equal to at plus bt square. Right, and what is initial and final time? So initial time is 1, final time is 2. Then that's simple. What is integration of t? So you have the formula, if you remember, integration of t raised to n dt is t raised to n plus 1 divided by n plus 1. Okay, power law of integration, right? It's option A. Let's check. So it is t square upon 2, right? Integration of t is t square by 2. This is t raised to 1, t raised to 1 plus 1 upon 1 plus 1, plus you have b, then it is integration of t square, it's t cube by 3. But then you need to apply the limits. Okay, so limits are 1 2 1 2, put the upper limit and then the lower limit. So x2 minus x1 is equal to a multiplied by upper limit. Okay, you can take that 2 also outside, right? You can take this 2 outside. So it's 2 square, you put 2 instead of t, so it is 2 square minus, then you put lower limit, so that's 1 square, 1 square is 1, plus b by 3 multiplied by, it is 2 cube minus 1 cube. Okay, so that is equal to, this is 4 minus 1, so that's 3 by 2, 3 by 2 a, plus this is 8 minus 1, so 7 by 3, 7 by 3 b, right? So it is option A. Right, good, Vishalini. Okay, so this is clear, everyone? Okay, this is very, very simple. It is from NEET 2016. Okay. Oh, just 1 second. Let me erase this quickly. Yeah, I guess nobody was able to solve, see the solution, right? I erased it very quickly. All right. So the displacement x in meter of a particle of mass m moving in one dimension under the action of a force is related to time t, is given by this thing. The displacement of particle when its velocity is 0 will be, tell me. You want displacement when velocity is 0. What will you do? What is given? T is equal to root of x plus 3, and I want the displacement of particle when velocity is 0. What should we do? So in order to find out velocity, okay, they are saying velocity is 0. First of all, what do you need to do? You know that velocity is 0 means dx by dt will be equal to 0, right? So first of all, you need x. So for that, find out x. Okay, so take that 3 on this side. So you have t minus 3 is equal to root of x, okay, square that. So you have x equal to t minus 3 square. So you got now the relation between x and t, okay, x in terms of t. Earlier t in terms of x was given, now you have x in terms of t. So just find out velocity. So what will be velocity? It is dx by dt. So that is equal to derivative of this thing, right hand side. So d by dt of this thing, t minus 3 square. So without expanding this, can you tell me what's the derivative? Yeah, anyone? Without expanding.
2 into
2
t
into
minus 3.
t minus 3, right? So okay, here we have used the chain rule. V is equal to 2 multiplied by t minus 3. Okay, so take the bracket, you have bracket square. Okay, so now just take derivative of the this thing, function of bracket. So it is 2 times the bracket multiplied by, take derivative of bracket. What is derivative of bracket? So inside bracket you just have t minus 3, so derivative of that is just 1. Okay, so that's why it is just 2 into t minus 3, right? This is the chain rule, remember, everyone? Okay, all right, this was simple one. Sometimes you have some other functions, okay, then it's more useful, right? Okay, so then you got v and you want displacement at v is equal to 0, when v is equal to 0. So put v is equal to 0. So if v is 0 means t minus 3 is equal to 0. Yeah, t is equal to 3. So if t is equal to 3, put that in x. Okay, you want displacement when the velocity is 0. So x when t is equal to 3, because at t equals to 3 the velocity is 0. So that is 3 minus 3 square, right? So that is 0. So the answer is 0. Okay, this is simple. Yes, no, everyone? Simple, not simple? Okay, good. All right, let's see next one. So the questions now will be like this. Sometimes you have to take derivatives, sometimes integrals. The motion of a particle along a straight line is described by this equation. This is the equation where x is in meter and t in second. The retardation of the particle. So what does the retardation mean? It means negative acceleration. Okay, when its velocity becomes 0. So they put the condition, when the velocity becomes 0, find out the retardation. That's it. So first of all, find out the point at which velocity becomes 0. So we have x equal to 8 plus 12t minus t cube. Okay, so then take dx by dt. V is equal to dx by dt, and that is equal to what? Take derivative of this thing. Derivative of 8 is 0. Derivative of this 12t is 12 minus derivative of t cube is 3t square, and you want it to be equal to 0, right? So first of all, you got the equation for v, and v is equal to 0 means 12 minus 3t square is equal to 0. So 3t square will be equal to 12, that is t square is 12 by 3, that means t square is equal to 4. So you got t square equal to 4, so you get two values of t is equal to plus or minus 2 seconds. Which one will you take? Plus 2 or minus 2?
+2.
Right, it's plus 2, okay, because time cannot run backwards. All right, so then just put that in the velocity, because you want to find out you want to find out retardation when the velocity is 0. Sorry, so you want to find out retardation when the velocity is 0. So you have velocity, the equation for velocity, take that, find a is what? Dv by dt, right? Find out the acceleration, dv by dt. So that is d by dt of this thing 12 minus 3t square. Okay, so that is derivative of 12 is 0, derivative of this thing 3t square, okay, it will be minus 6t, okay, minus derivative of yeah, it's option D, let's check. So 3t square is minus 6t, because derivative of t square is 2t, and you want it at t equal to, acceleration at t equal to 2, so that is minus 6 multiplied by 2, so that is minus 12 meters per second square. Okay, so the magnitude is 12, right? It's option D. Good. Okay, this is simple, right? Okay, let's see next one then. A particle moves along x-axis. The position x of a particle with respect to time from origin is given by x is equal to b naught plus b1t plus b2t square. The acceleration of the particle is, tell me. It's option D, 2b2. Good, very good. How did you solve? Yes, Yamini, how did you solve? Double derivative. Okay, 2 times, okay, good. 2 times differential, right. To find out acceleration, just find out d2x by dt square. So if you take dx by dt first, what do you get? That's d by dt of this thing, b naught plus b1t, okay, plus b2t square. Now I am explaining, so I have to write, but you can take derivatives in mind, right? So derivative of b naught is 0, then take derivative of this one, that will be b1 plus derivative of this thing. So b2 is a constant, so it will be 2 times b2t. So it is b1 plus 2 times b2t. Okay, then take another derivative. So if you take another derivative, d2x by dt square, so that is equal to, that will be equal to d by dt of this thing, b1 plus 2 times b2t, and then again this thing will be 0, derivative of this one is 2b2, and this is the acceleration, 2 times derivative of x with respect to time. Okay, that's good. Then see, if you have t square in the equation of x means position or displacement, then the acceleration would be, see, acceleration would be equal to 2 times the whatever term is there, right? If it is b2, it will be 2 times b2. Why is it so? Let me explain. Okay, you can just compare this one. So you can write this thing as x minus b naught is equal to b1t plus b2t square. So can you recall something? It resembles with some formula. s is equal to ut plus half at square, right? So that means u is equal to b1, okay, u is equal to b1, and a is half a is equal to b2. So if half a is equal to b2 means a is equal to 2 times b2. This thing is clear? Yes, no? Okay, so you don't even have to take two derivatives, because if you compare you get two things immediately. You get the velocity, initial velocity, and also you get the acceleration. Okay, right, just remember this thing. If x goes proportional to t square, okay, directly proportional to t square, or there is one term containing t, another term containing t square, then the acceleration would be what? The term multiplied, the coefficient of t square multiplied by 2. Okay, coefficient of t square multiplied by 2, right? So this is very, very simple. Okay, and if there is an equation like this, I mean x is proportional to t square, or there is some term containing t, some term containing t square, then this thing you can do, you can just compare it with s is equal to ut plus half at square to find out initial velocity as well as acceleration. Okay, all right. Okay, let's see next one. A particle moving along x-axis has acceleration f at time t given by this thing, where f naught and t are constants. F naught is constant, capital T is constant. The particle at time t equal to 0 has 0 velocity. So velocity is 0 when t is equal to 0, and if the time interval between t equal to 0 and instant when f is equal to 0, this thing is equal to 0, the particle's velocity is, okay, the particle's velocity is. So how do we find that? So what is this thing? What is f? It is an acceleration. The particle has an acceleration f. Okay, so not a standard notation, but they wanted to take it like that, right? So how will you find out the velocity? So you have v minus, we can say v2 minus v1, or vt minus v naught would be just equal to what? Integral of a dt from 0 to t, right? And they say that particle has 0 velocity at the start. Okay, it has 0 velocity, means v naught is equal to 0 at the start. The velocity is 0, so v naught is equal to 0. So v at time t is just equal to integral from 0 to t of a dt. So we need to take integral of this thing, but then we want what is this time t. Okay, so for that they have given another condition that f is equal to 0, the instant when f is equal to 0. So just take f is equal to 0. So f equal to 0 means f naught multiplied by 1 minus, okay, f naught times this thing is 0, 1 minus t by t is equal to 0, and that means if f naught is a constant, okay, it cannot be equal to 0. So 1 minus t by t is equal to 0. Okay, 1 minus t by t is equal to 0, and therefore t by t is equal to 1 and t is equal to capital T. Okay, so you got that. So small t is equal to capital T. So you got both limits. Initial limit is 0, final limit is capital T. So 0 to capital T, and what is acceleration? It is f naught, right? F naught multiplied by 1 minus t by t. Just integrate that. So it's very, very simple. Right? Okay, so let's integrate that. So f naught we can move outside. This is just f naught multiplied by integration of dt. Okay, I'm just multiplying with this dt from 0 to capital T minus t by capital T. Okay, integration of this thing from 0 to capital T. So take integral. So f naught will come in multiplication with this one also. Okay, so integration of this thing is just t, and lower limit is 0, means it's meaningless. Okay, so upper limit, you just have to put upper limit. So this is f naught times t minus f naught times, what's that, integration of t dt sorry, t dt would be t square by 2. You can take capital T outside, so it will be just t square by 2. Okay, so you can cancel out this one, so it is f naught times t by 2. F naught t minus f naught times t by 2 means it is f naught times t by 2. So that's the answer. F naught times t minus, yeah, f naught times t by 2. So half of f naught into t. That's the answer. It is option D. Right? Yes, no? This is slightly lengthy, but simple, right? Okay, so this is the answer. Let's see next one. A particle moves a distance x in time t according to equation this thing. The acceleration of the particle is proportional to. Now see the options. They say velocity raised to 3 by 2, distance raised to 2, distance raised to minus 2, velocity raised to 2 by 3. Okay, so what does it mean? It means that you need to find out the velocity as well as acceleration, both of them. Okay, but we'll anyways need to find out velocity also, because to find out acceleration we need to find out velocity first. So okay, what is velocity? It's dx by dt. Okay, so that is equal to, what is your x? So t plus 5 raised to minus 1. Take derivative of that. Tell me what's derivative of this thing. Using the power law. It's minus 1. What is derivative of this thing? Simple, no? Minus 1 multiplied by t plus 5 raised to minus 2. That's the derivative, right? And then you want to find out acceleration. So what will be acceleration? It's dv by dt. Okay, dv by dt. So that is a is equal to d by dt of this thing, minus 1 multiplied by t plus 5 raised to minus 2. So that is minus 1 multiplied by minus 2 into t plus 5 raised to minus 2 minus 1, that is minus 3. So that is 3 times t plus 5 raised to minus 3. And now you want to relate this one with either the distance or the velocity. So tell me. So velocity is proportional to t plus 5 raised to minus 2. Distance is proportional to t plus 5 raised to minus 1. You said something, Vishalini?
Multiplying acceleration power into 2 by 2, sir.
Multiplying that, yeah, you can do that. 2 by 2, right? So if you multiply that by 2 by 2, what will you get? 3 into t plus 5 raised to minus 3 by 2 into 2, minus 2 into 3 by 2 you can say, and this thing is what? T plus 5 raised to minus 2. So it's proportional to velocity to the power 3 by 2. Yeah, that's correct. Not equal to, we can say proportional to v to the power 3 by 2. So that is the answer. It's option A. Okay, this is also simple, right? Okay, good. So this is just little bit of adjustment. Okay, but it's simple. Let's see next one.
Sir,
Yeah, tell me.
sir, can you explain the last step?
This one.
Yes, sir.
So what you have done is you have multiplied this power by 2 and divided by 2, nothing else. Okay,
Okay, sir.
because
Yes,
you
sir.
have velocity is equal to something, some constant multiplied by t plus 5 raised to minus 2. That means velocity is proportional to t plus 5 raised to minus 2. Okay, and in acceleration you have t plus 5 raised to minus 3. So to check its relation with velocity, you are bringing this thing, okay, t plus 5 raised to minus 2. How can you do that? So minus sign is already there, t plus 5 raised to minus 3 is there, so you multiply with 2 and divide by 2. You have multiplied with 2 and divided by 2. So this thing is what? This thing is proportional to velocity. Okay, so this thing is proportional to velocity and you have power 3 by 2 of that. So therefore acceleration is proportional to v to the power of 3 by 2. Right?
Yes, sir.
Okay, that is simple. All right, let's see next one. The position x of particle with respect to time along the x-axis is given by x is equal to 9t square minus t cube, where the x is in meter and t in second. What will be the position of this particle when it achieves maximum speed along the x direction? Tell me, for the maximum speed, what do you need to do? You need to check. So v is equal to what? Dx by dt, right? So first of all, find out that v is equal to dx by dt. That means d by dt of 9t square minus t cube, derivative of that is 2 times 9 into t. Okay, derivative of t square is 2t minus 3t square. So that is 18t minus 3t square. This is velocity and you want maximum speed, maximum velocity. Okay, so what does that mean? It means that derivative of velocity would be equal to 0. Remember maxima minima, at the position of maxima, at the position of minima, the derivative of a quantity is equal to 0, right? So when velocity is maximum, what happens? If you plot the velocity versus time graph, if it goes something like this, let's say at maximum velocity, if you find out its slope of the graph, that is equal to 0. Okay, so at Vmax, dv by dt would be equal to 0. And tell me what will be second derivative of v with respect to time? It will be positive, negative? Positive or negative? It has to be negative, right? At maxima, second derivative is negative. At minima, second derivative is positive. Okay? Yes, no, remember that, right? Okay, so at Vmax, dv by dt is equal to 0 and second derivative is negative. If it was minimum velocity, dv by dt is still 0, but second derivative would be positive. Okay, all right. So let's check dv by dt. So dv by dt is equal to, take derivative of this thing, so it's 18 minus 60, right? And that should be equal to 0. That means 60 is equal to 18, or t is equal to 18 by 6 means 3 seconds. But then you got only one value, so you don't need to check the double derivative, right? because you got only one value. Okay, if you got two values, then you need to check the double derivative. Okay, and mostly will not get two values. Mostly I am saying, okay, there can be an exception. Mostly we'll just get one value where derivative would be equal to 0 in NEET. Okay, all right. So we want position when velocity is maximum. That means derivative of velocity is 0. So we got the time when this thing happens, t equal to 3 seconds. So position is equal to what? 9t square minus t cube. So put t equals to 3 there. So 9 times 3 square minus 3 cube. So that is this is 9, 81 minus 27. How much is it? It's 54, right? Okay, this thing is clear? Yes, no?
Yes, sir.
Okay, so see here also I have, okay, while doing this calculation, now that's not very difficult, you can subtract it, but I have used a small trick. So let me just tell you, maybe it would be helpful to you. So I wanted to do 81 minus 27, right? So what I did, okay, what I did basically, so I subtracted 30 from 81, so I got 51. Okay, but I over subtracted by 3, so I added 3. So that's why it's 54. You got it? Yes, no? Okay, you can see that I was able to do that very quickly. So this is, I do these kind of tricks. Okay, so maybe it's helpful, it might be helpful to you also. Okay, it might save your 1 or 2 seconds. Every second is important, that's why. All right, good. Let's see next one. A particle is traveling along a straight line OX. The distance x in meter of particle from O at time t is given by this thing, where t is in second. The distance of particle from O when it comes to rest is. Tell me. So these are similar kind of problems, right? Distance of the particle from O when it comes to rest is. So this is simple, just find dx by dt. It comes to rest means the velocity would be equal to 0. So d by dt of this thing, 37 plus 27t minus t cube. Okay, so this thing is just 27 minus 3t square, because derivative of 37 would be equal to 0, and this is equal to 0 because particle comes to rest. So 27, so v is equal to 0 means 27 minus 3t square is 0. Okay, and that is 3t square is equal to 27. So t square is 9, so t is plus minus 3, we'll take plus 1, right? T is equal to 3, and you want distance from origin, so just put that over here. So you get x equal to 37 plus 27t minus t cube. So 37 plus 27 times 3 minus t cube is what? 3 cube. Okay, so this is 27 times 2. Okay, no, this is 27 times 3 only. Sorry, what am I saying? Okay, I calculated it first. So this is 27 and it's 3 minus 1, so it's 27 times 2. 27 times 2, that's 54. 54 plus 37. How much is 54 plus 37? 91, right? So the answer would be 91. Yeah. So x will be equal to 91 meters. Okay, but then this is simple. They said that what will be its distance from the origin, but if they say what will be its distance from the starting position, tell me what what will be the distance from the starting position? Anyone? Distance from the starting position? Suppose this equation is given, tell me what's the starting position. Yeah, good, Yamini. That will be distance from the starting position. So starting position is 37, right? When you see this equation, x is equal to 37. Okay, this thing is starting position, right? You can compare this with x is equal to x naught plus some function of t. Okay, so this constant term is starting position. Remember that in the equation of x, okay, in equation of position, the constant term, the term that doesn't contain time, is starting position. Okay, remember that. All right, so let's see this one. The acceleration of a particle is increasing linearly with t is as bt. The particle starts from origin with an initial velocity v naught. The distance traveled by particle in time t will be, okay, the distance traveled in time t will be, tell me. Acceleration is given, right? Acceleration is given, a is equal to bt, and you want distance, so just double integrate that, right? So if you integrate this thing, a dt from 0 to t, what will you get? You will get v at time t, okay, v minus v naught, right? You will get v minus v naught. Okay, so what is a? A is bt, so just integrate that. So bt dt, integration of that will give you what? B you can take outside, integration of t just t square by 2, and lower limit is 0. It's option C. Okay, might be, let's check. So it is b times t square by 2, half of bt square. Okay, and then you want the distance sorry, the distance x minus x naught just equal to integration of v dt. So what will be v? Take that v naught on other side. Okay, so v is equal to v naught plus half bt square. Okay, you need to integrate that. So that is v naught times, okay, dt, v naught times t. If you integrate this, okay, and integration of this thing will be t square by 3. Yeah, so it is half of b times t square by, sorry, t cube by 3. I said t square, it will be t cube by 3. So 2 times 3 is 6, so bt cube by 6, v naught times t plus bt cube by 6. Yeah, so it is option C. Good, correct. Right. So the questions would be like this, right? Okay, so we'll stop here. There are little number of questions left, and one more topic is there, which is known as relative velocity. Okay, sometimes, very few times, but there are questions asked based upon that topic also. Okay, so we'll stop here. Tomorrow we'll see the next part. Okay, one more thing. So very few of you have attended, written the test. Okay, the test will be available for you for this week, right? Till Saturday it will be available. On Sunday I will upload the next test, so this will be deleted. Okay, so please solve the test. Okay, if you have any doubts regarding how to take the test, etc., you can ask me. All right, but please solve the test. Okay, and some students have solved the test, like Yamini has solved, and I guess nobody in this class right now who are present. Okay, they have not solved. Others, some are absent, so some of them have solved. So performance was, I can say it's okay, but the test was simple and time given was 45 minutes for 30 questions. Okay, so yeah, welcome. All right, so Yamini's performance was good, no problem. Okay, but you can improve upon that. You took 45 minutes, no Yamini? Okay, all right, no problem. This was first test, so it will keep on improving. So for now we are just checking how many questions can we solve given the sufficient time, and 45 minutes is more than sufficient because you will get only 45 minutes for 45 questions. So right now I am giving 45 minutes for 30 questions. Okay, so you need to increase the speed also, but for now let's check whether our concepts are clear or not. For that I am giving 45 minutes. Okay, so please give the test, and your scores nobody else is able to visible, it's between you and me, so don't worry at all. Okay, so just like suppose I have some problem when I visit a doctor, right? Suppose I am in stress or something like that, I need to tell my condition to the doctor, right? So right now I am your doctor. Okay, think of it like that. So you will be a doctor someday, right? So you will expect your patients, you're not a patient, you are students, but you can relate it to that. So your score will be in between you and me. Please give the test. If you don't give test, then don't expect anything from the class. Yeah, every Sunday there will be a test. Okay, all right then, let us stop here. Okay, have a good day. Please give the test. Okay, bye.